Okay, let's look at the derivatives of exponential functions. All right, so if you have e to the x and you want to take the derivative of that function, the derivative is itself, e to the x. All right, so we like this function. Whenever you take the derivative of e to the x, you get the same thing back. All right. And if you have a base other than e, it's slightly different. So the derivative of, say, b to the x, then the derivative is going to be itself, b to the x, multiplied by natural log of the base. Natural log of the base. Right? So let's look at a few examples. Right? So you have f of x is equal to negative 7 e to the x minus 2x plus 5. Let's find the derivative. Right? F prime of x is equal to, right? So negative 7 is just a constant, so it's a constant multiple. I'll just put it in front. Right? Then derivative of e to the x is itself, so it's e to the x. Right? Then after that, we know what to do. Derivative of negative 2x is negative 2. And derivative of 5 is 0, since 5 is a constant. So f prime of x that we're looking for is negative 7 e to the x minus 2. Right? Let's look at the second example. Right? So y equals e cubed minus 3 to the x. Right? So let's take the derivative. So we have a y prime is equal to, right? So you can see that the e cubed is not an exponential function. It's a e cubed is just a constant. There's no x involved. So derivative of a constant is 0. I'm not going to write anything down there. All right? So you have a negative sign here. So I'm going to put a negative sign, right? But the derivative of 3 to the x is itself. So I'll just write down the itself first, 3 to the x. Right, 3 to the x, but we need to multiply by natural log of the base, in this case 3. Right, so this is the derivative of that we are looking for. Alright, so let's look at another example. This is an example where we need to find an equation of the tangent line. Alright, so you have a function f of x is equal to 2 plus e to the x. And we want to find an equation of the tangent line to the graph of this function at x equals 1. Alright, so let's do that. So whenever we look for an equation of a line, we need two pieces of information. And the first one is a point. Right, let's call it x1, comma y1, which is equal to, right, x value is already given, which is 1. So I'm going to just, right, so this is x1 right here. Right, so x1 is 1. All right. And then y1 is just, you just have to plug in plugging 1 for x, f of 1, which is going to be equal to 1, comma, all right, so plugging 1 here, 2 plus e to the first power is just 2 plus e, 2 plus e, all right? And we need to find the slope, so slope is going to be, we're going to use a lowercase m, right? So in order to find a slope, we need to find a derivative. So from here, let's find a derivative. So f prime of x is equal to, all right, so derivative of 2 is 0, since 2 is a constant, and the derivative of e to the x is itself, so e to the x. All right. so we can find the slope of the tangent line by evaluating a derivative at x equals 1. Right? So that's going to be e to the first power, so that's going to be e. Alright, so by using the point slope form, remember the point slope form goes like y minus y1 is equal to slope m times quantity x minus x1. Right? Let's put those numbers in there. So y minus y1 is 2 plus e. So it's 2 plus e. It looks a little bit ugly, but that's okay. Then you have a slope is e. And x minus 1. Right? If you want, you can simplify this a little further. You can, distribute the negative sign to 2 and e. We have y minus 2 minus e is equal to, right? And also distribute e to x and a negative 1. So that's going to be e to e times x minus e. Right? Then we can, since there's negative e in both sides, you can cancel e and cancel negative e here by adding e to both sides. And last one, I'm going to write it in a slope intercept form by adding 2 to both sides. So you can see that you're going to have a y is equal to, right? So this 2 is placed over to the other side. So you're going to have e to the, sorry, not e to the, ex and plus 2. Right? So this is an equation of the tangent line that we are looking for. All right, that's it. I hope that this was clear.